In this video, we'll take a look at critical numbers and extrema. In our last video, we ended with an observation. We said that minimum or maximum values occurred only at a hill or at a valley, and at that point, the tangent line is horizontal. We also said the slope of those horizontal tangent lines would be 0. That's for each of those horizontal tangent lines. So now we have to do the math. So one way to find the location of a minimum or maximum, so this is going to give us the x value only of a minimum or maximum, is to find the derivative of the function, which of course the derivative is the rate of change. So f prime of x, that's, remember, our slope, and we're going to set that equal to 0 to find the location of the zero slope tangent line. So let's try it here. Y prime is equal to 3x squared minus 3. Now I'm going to set that equal to 0 because I want to know where is the slope equal to 0. So 3x squared minus 3 equals 0. Solve it how you like. Let's go ahead and add 3 to each side, divide by 3 on each side, and take the square root. So what I have found is that x occurs at plus or minus 1. Notice here this is minus 1 and this is plus 1. Now keep in mind that does not give me the min or the max. That gives me the location of the min or the max. Okay, so just the x value. Now how would I find the y value, which is the min or the max? I of course would go back to my original function. So for instance, y equals -1 cubed minus 3 times -1 would be -1 plus 3, which gives me 2, so that's what give me this value, and I could do the same for plugging in +1. What we didn't talk about in our last video is that it's also possible to have a minimum or a maximum at a sharp corner. At that point, we would not be able to find the derivative. It's not differentiable at that point. Now, we don't know how to find the absolute value derivative yet. So for now, let's just keep it simple and remember that the derivative is the slope function. So I can simply look at the slope from each side and keep in mind that if one-sided limits don't exist, if one-sided limits are not the same, the derivative does not exist. So I'm going to find the limit as x approaches 0 from the left of y prime. So essentially I'm saying, as I'm coming to this point from the left-hand side, what is the slope of this line? Well, the slope of that line I can find very easily is I go down 1 and go over 1. So that's a slope of -1. Now, if I do the same from the right side, the slope as x approaches 0 from the right of the derivative, that means, of course, that this is a positive slope. I'm going up 1 to the right 1, so that's +1. Because those two one-sided limits disagree or differ, the derivative does not exist. So the derivative does not exist at this point. This brings us to critical numbers. The only place that a minimum or maximum can occur is at a critical number. Critical numbers occur when either the derivative of our function is equal to 0 or f is not differentiable. So those are the two instances we just looked at when we have a horizontal tangent line or it's not differentiable, so we have a corner. That is where a minimum or maximum will occur. Keep in mind, however, that you may have critical numbers that are neither a minimum or a maximum. So a couple of theorems. Again, this first theorem we've talked about. Let f be defined at c. If f prime of c is equal to 0 or not differentiable at c, then c is a critical number of f. And if we have a minimum or a maximum, then c must have been a critical number. Okay, but notice it doesn't say if C is a critical number, you must have a min or a max. So that's a very important distinction because we will have critical numbers that are neither. So let's get to the math. What we want to do is find the extrema of this function on an open interval. So again, it's extrema on an open interval, so now I don't have to worry about endpoints. So what would I do first? Well, I want to find f prime of x. So let's do that. F prime of x is equal to, and again, just using all of those rules that we learned in our last chapter. So that's 3 times 4 is 12, x to the third, and then minus, and then 12x squared. And next step would be set f prime of x equal to 0. So now I'm going to say 0 is equal to, and I'm going to go ahead and factor out a 12x squared, which is going to leave me with x minus 1. I need to find those values of x. So now I have x is equal to 0. That would come from this point. And this is actually a multiplicity of 2 because I would have 2 zeros there. And that is actually going to come into play. And then I would have x is equal to 1. Now, am I done? No, all I have done is found the x values, but we are asked to find the extrema. So I need to find the y values. So now I'm going to, let's pick a color, back to blue. Plug in the critical numbers to f of x. So these are critical numbers. And in this case, we can see that there would be no places where it's not differentiable. So how do I know it's differentiable? It's a polynomial function. And we already talked about the fact that a polynomial function is going to be continuous and differentiable over the entire domain. So now let's plug in our critical numbers. So I'm going to find f of 0. F of 0 is 3 times 0 to the fourth minus 4 times 0 to the third, which of course is 0, which means the point is 0, 0, but the value that I'm interested in is 0. And then I'm going to look at f of 1, because I'm using the critical numbers, so f of 1. F of 1 is 3 times 1 to the fourth minus 4 times 1 to the third. So that gives me 3 minus 4, which gives me negative 1. So the point is 1 comma negative 1, but again, what is the min and the max? So the min, and this would be relative. How do I know it's relative? Because I have an open interval. So the relative minimum is negative 1 at 1 comma negative 1. The relative maximum is 0 at 0 comma 0. Now you can always graph the function, and by graphing the function you can see the visual that shows where that min or max exists. Now we're going to find the extrema on a closed interval. So the good news is the steps involved are to, 1, find the extrema on an open interval, which is everything we just learned how to do, and then plug in the endpoints of the interval. So super duper easy. It's going to look exactly the same, except remember on a closed interval we can have a min or a max at the endpoints. So you'll notice that when I start this question, I'm going to take f prime of x is equal to 12x cubed minus 12x squared, just as I did before. I'm going to set it equal to 0 to get 12x squared, and then x minus 1. And then I'm going to say the critical numbers are x equals 0 and 1. And then when I plug in the values, I'm plugging in 0, which we determined was 0. I'm plugging in 1, which we determined was -1. But now I'm also going to plug in -1 and 2, because those can also be min or max values. So if I plug in -1, again, that's back into the original function, because I want to know the y value of the original function. This is 3 times -1 to the 4th minus 4 times -1 to the 3rd. That's 3. And then that's minus, actually plus 4, because it's minus a -4. So that gives me 7. So I can see that I have a new max unless f of 2 is greater than that. So 3 times 2 to the 4th minus 4 times 2 to the 3rd. 2 to the 4th is 16 times 3 is 48. 2 to the 3rd is 8 times 4 is 32. If I subtract, I get 16. So now I know that my max is 16 and it occurs at 2, 16. And I know my min is -1 and it occurs at 1, -1. And again, you can always graph it to verify your results. So I can see now that I've graphed it that at 1, -1 is definitely the minimum, and 2, 16 is definitely the maximum. Let's look at another practice together. Notice this is a closed interval, which means in addition to whatever critical numbers I might find, I need to plug in the endpoints of my interval as well. So let's start by finding f prime of x. And f prime of x is equal to 2 minus, and then of course I've got this 3x to the 2/3. So I have 3 times 2/3 x to the -1/3. So do a little bit of cleanup on that. That should help. So 2 minus, obviously these cancel out, and I have 2 and then x to the 1/3. Now I can leave it just like that, or I can put it together into one fraction. It doesn't matter. I'm going to leave it just like this. Now remember, we need to find all of the points where f prime of x is equal to 0. So 0 equals 2 minus 2 over x to the 1/3. So I need to do that, as well as I need to be thinking about where it might be undefined, because in our last question we didn't have any places where the derivative didn't exist. So here, first let's just start with the easier one. I know that 0 is equal to 2 minus 2 over x to the 1/3, or cubed root of x. So if I just move things around a little bit, add 2x over x to the 1/3 to each side. Now I can divide each side by 2, so 1 over x to the 1/3 is equal to 1, which means x to the 1/3 is equal to 1, because of course I could just do some cross multiplication, which makes it pretty straightforward. Now keep in mind that all I would do then is cube each side, so x is equal to 1. So that is a critical number. However, there's more than one critical number, because now we have to talk about, this was when f prime of c was equal to 0, and now I have to say when f prime of c is undefined. And we didn't have to do that on our last one, again, because it was a polynomial function and it was never undefined. So when is this going to be undefined? Well, it's going to be undefined when x is equal to 0, because if I have 0 in my denominator, obviously that's an undefined function. So that means my critical numbers are 1 and 0. So critical numbers 0 and 1. But I also have to plug in -1 and 3 to determine min or max. So again, I'm just using this function right here. I'm saying 2 times 1, which is 2, minus 3, and then 1 to the 2/3. Well, obviously, the cubed root of 1 is 1, squared is 1, so that's just 2 minus 3. And I get -1. If I plug in 0, that's just 0 minus 0, which is 0. So that one's easy. If I plug in -1, I get 2 times -1, which is -2. And then minus, I've got -1, and then the cubed root of that is -1. I square it, I get 1. Take 1 times 3, so it's -2 minus 3, which is -5. And this last one is a little bit ugly because it's 2 times 3, which is 6, and then it's 3 times 3 to the 2/3. Well, there is no nice cubed root of 3 that I can then square, so just break your calculator out on that one and find that the result is about -0.24. So that's just an estimation. I could leave it like this to show the exact solution. So now again, what are the extrema? I need to find the min and the max. So the minimum value is at -5, and again at -1, -5. The maximum value appears to be at 0. So 0 is a max, and that's at 0, 0. And again, always helpful to have a picture. Let me get rid of my writing here. And we can see that at 0, 0, there is a sharp corner just as we expected, because that's where the derivative did not exist. So it's not differentiable at that point. And then of course at -5, that's our min. So that's our min and our max. I debated whether or not to throw in one practice, but again, I wanted to make sure we had practice in finding the derivative that wasn't super straightforward. So again, this is a closed interval, so I'm going to have to plug in the endpoints, but the first thing I do is find f prime of x, and we will have to use the quotient rule, and that's why I threw this one in. So the quotient rule says take the bottom, which is x minus 2, times the derivative of the top, so that's 12x, minus the top, 6x squared, times the derivative of the bottom, which of course is 1, and then I've got x minus 2 quantity squared on the bottom. Now I'm going to set that equal to 0 and say, let's do some cleanup. So 0 is equal, this would be 12x squared minus 24x minus 6x squared. And of course, I would then be able to simplify that a little bit further to get, 6x squared minus 24x over x minus 2 quantity squared. I'm going to go a step further and say that's 6x and then x minus 4 over x minus 2 quantity squared. So again, what are the critical numbers? Critical numbers would be when this function is equal to 0, obviously. And so when I'm looking at a rational function like this, where I have a ratio, I have to look at when does the top equal 0. So basically, I'm going to say 6x times x minus 4 equal to 0. And that would give me x is 0 and x is 4. Oops, critical numbers, x equals 0 and 4. And then I also have to look at when the bottom is equal to 0, because that is when the derivative is undefined, right? So that would be x is equal to 2. Now, from here, I have to look at the interval. The interval goes from -2 to 1. So that means even though I have critical numbers of 0 and 4 and 2, I don't care about the 2 because it's outside of my interval. and I don't care about the 4 because it's outside of my interval. So I only have to check f of 0, which is going to be 0 in my numerator, so that's just 0. I have to check f of negative 2. That would give me 24 in my numerator and negative 4 in my denominator, so that's negative 6. And then I have to check 1, which would give me 6 in my numerator and negative 1 in my denominator, and that would be negative 6 as well. And so again, I would have a max of 0 and a min of negative 6 that occurs in 2 places. Just a touch over 20 minutes so I could get through that last example. Up next, we're going to take a look at Raleigh's theorem.